Math Morning, Mr. Durkis here. Today we will be graphing linear inequalities in two variables,
Now let's play a little game. I want you to guess how many cats I'm going to put in this video. Take a guess right now, and I'll answer at the end.
Alright, how many? How many cats? How many so far? Let's begin this lesson. So just like in the previous videos, we're going to take stuff that we already know and put it all together. The first one says, is 4, 3 a solution to 2x minus y is less than 4? So I know that this 4 is an x, and I know that that 3 is a y, so I'm going to take these numbers and substitute it into this inequality. So 2 instead of x, I put in 4, minus y instead of y, I put in 3, is less than 4. Now I multiply 2 times 4 is 8, minus 3 is less than 4. 8 minus 3, that's 5. It's 5 less than 4. Is this a true statement? No, it is not. So your answer is no. This one down here is negative 2, 0 a solution to y is less than 2x plus 4. Alright, so again, that's the x, that's the y. I substitute into the equation. So instead of y, I put 0 is less than 2x, right? X is negative 2 plus 4. When I simplify 0, 2 times negative 2 is negative 4 plus 4. 0 is less than negative 4 plus 4, that is 0. This is a true statement. 0 is less than 0. No, it is not. No. If this had a little line under each one and it was less than or equal, then it would be true, but it's just less than, so it is not equal to no. No, no, no. Alright, so now we're going to graph linear inequalities. I want you to pause the video, copy down these 3 directions. Alright, awesome. So first one, put the line in slope-intercept form and graph it. If you remember, slope-intercept form is y equals mx plus b. This inequality is already in that form. We have the y by itself, and then the slope, and then the y-intercept. So it's like that, so let's graph it. The y-intercept is negative 3, so that means I start here, I go down 1, 2, 3. I start right there. And the slope is negative 1. There's no number there, that means it's negative 1. So that's negative 1 over 1. So I start here, I go down 1 over 1, down 1 over 1. I can go the other way, up 1, left, up, bam, 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 bam. Alright, step number 2. You have a dashed line for less than or greater than, right? You have dashed, that means dashed. And a solid line for less than or equal to or greater than or equal to. These were similar to when we were doing the regular inequalities and we had an open circle and a closed circle. So for the ones that had an open circle, we use a dashed line. Closed circle, we use a solid line. So this one is y is less than or equal to, so we're going to use a solid line. Yeah, that line's not so bad. Not so bad. Good job, Mr. Durkis. Alright, third step. Shade depending on test point or shortcut. So there's 2 different ways. The first, I'm going to show you the test point. If you remember when we did the other inequalities, like if you had a number line and it was, we pointed one direction. So it's not just one number, it's a whole bunch of numbers. And when we do this, we're going to shade either the top above the line or below the line. And we do that by testing points. So there are many points I can test. I could test this point, I could test that point, but my favorite point is right there. My favorite point is 0, 0. Why is it my favorite point? Because it's the easiest to work with. Zeros is a great number to use. So what I do, I take these numbers, right? Remember the first one is a x and the second one is a y. And I put it into my inequality and I see if it's true or false. So let me do that right here. the y is 0, less than or equal to negative 0 minus 3. Now I have 0 less than or equal to minus 3. Is 0 less than or equal to negative 3? No, it is not. No. So that means this point right here, it can't work. It cannot work. So what that does mean is that all these points on this side over here must work. So the side that does work, I shade in. Right? I shade it. Could be any point on this side of the graph. If I want to test one, I can, and just to make sure that it really does work. So if I try it this point right here, this is negative 3, negative 2. So I take these numbers, I put them into this equation. The y is negative 2. Negative 2 less than or equal to, the x is negative 3. It's already negative x, so I write negative 3 minus 3. So it's negative 2 less than or equal to, this becomes positive 3. Positive 3 minus 3, it's 0. Is negative 2 less than or equal to 0? Yes, it is. So this point worked. And if I tested any other point on here or on this line, because it's a solid line, it would work. Alright, so this one, the first step was put it in slope-intercept form. So let's do that. We have x plus 4y is greater than negative 20. I want to do a minus x, those cancel. 4y greater than negative x minus 20, divide by 4, that cancels. I have y is greater than. This becomes negative 1 over 4x, and this becomes minus 5. Alright, first step done. So when I graph this, I go down to minus 5. 1, 2, 3, 4, 5. That's the y-intercept. And the slope is negative 1 over 4. So I go down 1 and to the right 4. I can also do the opposite. Up 1 to the left 4. Up 1 to the left 4. So I have the points. Now I need to know, is my line solid or dashed? Well, this is greater than. It's not greater than or equal to, so it has to be dashed. Let me see, does this dashed pen work? So I draw that. Oh, check that out. Dashed. Alright, awesome. Put the little arrows on the end. So now I need to test a point. You can choose any point you want as long as it's not on this line. 0, 0, that one's going to be the easiest most of the time because zeros cancel things. So let me test it. 0, 0, right? 0, 0. So I put in 0 for y. 0 is greater than negative 1 over 4 times 0 minus 5. This cancels right there. Negative 1 over 4 times 0 is just 0. So is 0 greater than negative 5? Yes, it is. It's true. So that means every number above the line will be shaded, and every number, every ordered pair will work. Alright, so bam, shaded. Everything above here works. Everything below the line does not work. Alright, so the first way of graphing these was testing a point. That's how you found out what side was shaded. Now I'm going to show you the shortcuts. But first, let me just graph this. So y is less than negative 6 over 5x plus 1. So the y-intercept is plus 1, and the slope is negative 6 fifths. So I go down 6, 1, 2, 3, 4, 5, 6, and to the right 5. 1, 2, 3, 4, 5. Bam. And I could, can I go up 6 over here? 1, 2, 3, 4, 5, 6. No, I'd be off the chart. Alright, so it is less than. It's not less than or equal to, so that means I have a solid line. Nope, not solid. I lied. A dashed, right? When you have less than, it is dashed. So let me connect these with a dashed line. Alright, perfect. So copy these definitions now, pause the video, copy them. It says if y is greater than mx plus b, or y is greater than or equal to mx plus b, then above the boundary line. So we have greater than, or equal to. So if this up here was greater than, you would do above the line. If y is less than mx plus b, or less than or equal to, you do you do below. So if it's less than or equal to, you do below. If it's greater than or equal to, you do above. What does this mean? You look at this, what is above and below? So if we're trying to do below, right, if you just put your pen on the line and you draw an arrow going down, that is everything below the line. Sometimes it can get a little tricky depending on how steep the line is, but if you just put your pen on it and draw a line going down, that's below. You can also think about rain, right? If I have a rain cloud and rain's coming down, you want to be below the line to get away from the rain. Alright, so that's how it works. We can check the other ones, see if that was actually true. Alright, so this one was y is greater than, bam, above the line. Let's see. There we go. This one was y is less than or equal to. That one was below the line. So the shortcut does work. So now we're going to try some real problems putting this all together. So Mr. White and Mr. Fawn are raising funds for a big trip to Cape Cod. These guys, they love the beach. Mr. White makes about $15 for every hour he works, and Mr. Fawn makes about $5 for every hour he works. They figure they need to make at least $100 to go. Alright, so write an inequality. I'm going to say that Mr. White is X and Mr. Fawn is Y. So let me see. Mr. Fawn makes about 15 for every hour, so that's the X. We have 15X. And Mr. Fawn makes $5 for every hour he works, so that is 5Y. They figure they need at least $100 to go. So I've got, they need $100, at least $100. So can they have more than $100? Yes. Can they have exactly $100? Yes. So this is going to be greater than or equal to 100. And they're working together. They're putting their money together to go. So we're going to add these two together. So this is the equation. This is Mr. White, that's Mr. Fawn, and they need to make at least $100. Graph it. So I need to put it in y equals mx plus b before I graph it. So I do a minus 15x minus 15x. And that cancels. We have 5y is greater than or equal to minus 15x plus 100. Then I divide by 5, that cancels. Y is greater than or equal to minus 3x plus 20. So this is the equation. Let me graph it. The y-intercept is 20, so that's right up there. Bam. The slope is minus 3, so that's minus 3 divided by 1. So I go down 3 to the right 1. Down 3 to the right 1. Down 3 to the right 1. Down 3, right 1. Down 3 to the right 1. Bam, just like that. Will the line be dashed or solid? Well, it's greater than or equal to, so it's going to be a solid line. Solid line. Bam. And where do I shade? The below or above? It says y is greater than or equal to negative 3x plus 20. So greater than or equal to, that is above. Remember, you draw arrows going up for above. So it's everything up here. Any combination up here would work. So what are 3 possible combinations that would allow them to go to Cape Cod? So if we remember, who is X? Mr. White. And Mr. Fawn is Y. So I can choose any point on this line, because it's solid, or above it. So let me choose this point right here. That is, if I go down, X is 5. And Y is 11. So that point works. So that'll be if Mr. Fawn or Mr. White worked 5 hours, and Mr. Fawn worked 11. Right? That one works. This point over here, this is also above that line. That point is 10, 0. 10, 0. That means Mr. White works he works 10 hours, and Mr. Fawn works 0. Another point, I could choose all the way up over here too. That point is X is 10 and Y is 22. So that's 10, 22. So Mr. White works 10 hours, Mr. Fawn works 22 hours. Is this $100? No, it's a lot more, right? It can be at least $100. So it can be anything above that line. So that's why these can be a little tricky, because it's not just one solution, it can be an infinite amount of solutions. But everything above this line would be a good combination. Alright, here's what I want you to do by yourself. So pause the video, try this one by yourself. Alright, let's do it. First step, put it in y equals mx plus b. So we have 5x plus 4y less than equal to negative 12. So I'll do minus 5x minus 5x. That cancels. I have 4y less than or equal to negative 5x minus 12. Then I divide by 4, divide that by 4. That cancels. Y is less than or equal to negative 5 over 4x minus 3. So I graph it. Bam, that's the y-intercept, minus 3. And the slope is negative 5/4. I can go down 5 to the right 4. That's off the graph. So I can do the opposite, which means up 5 to the left 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. If you remember, right, a negative slope, which this is always going from left to right downhill. So will this line be solid or dashed? Right, it's going to be a solid line because it's less than or equal to. So I connect it with a solid line. Pretty good line, Mr. D. And its y is less than negative 5/4 x minus 3. So less than is below that line. It's below. So there we go. Shading everything below that line. So that's it. Before I go though, let's count up the cats, right? That was the challenge at the beginning. How many cats did I put in here? How many? Going back, here we go. We've got 1. But did we only have 1? I believe I had another one. Hang on. There's this video right here. That's the second cat. Bam, 2. Nothing there. 3, 4, 5, 6, 7. On my shirt. 8. This guy right here. 9. 10. 11. And lastly, this guy, 12. So there were 12 cats in the video. If you guessed that, good job. Good guess. So that's it. Good luck on the mastery check. Good luck on the quiz. You got this. Darkus out.